Back for part 2 of the oblique asymptotes lesson. Oblique, another word for slant. Slant asymptote, oblique asymptote, they're both fine. Here's our little conclusion, box-worthy conclusion. To find the oblique asymptote of this function, what's the condition? The degree of the top must be one more than the degree of the bottom. Last class we said that there was no horizontal asymptote, and that's true. If the degree on the top is only one more, then it's a slant asymptote. And the process is we use long division, and the quotient is the oblique asymptote. So what do we got? Find the equation of the oblique asymptote. There's the function, and then sketch the graph. So we're going to do this. Get the color going here. So how do I find the equation of the oblique asymptote? Well, notice that it does meet the criteria. The top is of degree 2, and the bottom of is degree 1. We know there's no horizontal asymptote. Since it's the degree is 1 higher, we know that there's an oblique asymptote. We find that using long division. Asymptote. So long division, I'm going to take x minus 4 and divide into 3x squared minus 6x, and then a placeholder for the constant term. And now 3x squared minus 12x, subtract, and I get 6x. The 0 comes down, plus 6, 6x minus 4, subtract, and I get 4. So what's the oblique asymptote? Right there. Y equals 3x plus 6 is the oblique asymptote. Dandy. Sketch the graph. Okay, and notice that it's not giving us any other support besides just asking us to sketch the graph. So how are we going to do that? Well, I am going to do a whole bunch of analysis still. Oops. I'm actually going to set up a grid this time and use a decent scale, just because to draw the oblique asymptote, it's nice to have some graph paper. So I'm going to use graph paper. All right, I've got to get rid of this first, I suppose. Crappy set of axes. Get rid of that, get rid of you, and I'm going to put a grid on here. All right. Notice even this is going to be tough because the scale is so big, right? I'm starting down at up at positive 6, and then my slope is 3. I'm going to have to change my scale on my y-axis just so I can fit this graph in. I'll show you what I mean. So in this direction, I'm going to have this 2, 4, and so on. But in this direction, to fit the oblique asymptote on there, I'm going to go up by 3s. So that's 3, 6, and 9, and 12. And so it starts at 6, and the slope is 3, right? So the y-intercept is 6, the slope is 3, up 3, right 1, up 3, right 1, up 3, right 1, up 3, right 1, up, and so on. That's my oblique asymptote. So I'm going to draw, oops, my oblique asymptote through there. Looks pretty good. The thing is what's the rest of the graph though? Well, I have to do those other things that we've been practicing to figure it out. X and Y intercepts, right? Let's do them. Where's the... I'm going to copy it down here. Minus 6x over x minus 4. And when x is 0, y is 0, right? So I got that point right there. And in fact, that's going to spoil this other calculation because the x and y intercepts happen to be the same. But I might get a second spot where where y is 0, right? It's possible for this graph to have more than one x-intercept. So x-intercept is when y is 0. And as long as x is not equal to positive 4, rather, then I can cross multiply and I get this little quadratic equation. And no, I don't have to use the quadratic formula, but you could. This is way easier than that. So I get my first root is the one that I had before, right? This gives me x equals 0 or x equals 2. So I did actually have a use for that other 0, x equals 2, y equals 0. So I got another point there. All right, I still don't see what's going on. Can't see what's going on with this graph. Well, let's keep going. What else would we like to know? Vertical asymptotes. Right? When x equals 4, I get a vertical asymptote. So I'm going to draw my vertical asymptote in there. Right, good. At x equals 4, vertical asymptote. Slant asymptote of y equals 3x plus 6. And then now what happens? Like, do I get a picture of this graph? Well, I could investigate the behavior near the vertical asymptotes, but I think I've got it. I know it's got to get close to this slant asymptote, and it's got to get close to this vertical asymptote. So it's going to do something like this, isn't it? It's not going to wobble like that. You can do a better job than I did. And then over here, it's kind of hard to see. I know it's got to get close to the vertical asymptote, and it's got to get close to the oblique asymptote. Is it going to be on this side? No way. It's not, because there's no other x-intercept. It's got to be up here somewhere. And again, I could investigate the behavior near a vertical asymptote to know that it goes to positive infinity. But just using my noggin here, I know that there's no other x-intercept at 5 or 6 or whatever. So I know it's not going to be this way. I know it's got to be here. And that's it. Done. Now, there are some troubling things. Again, I don't know how far up to go, and I don't know how far down to go, even though I could pick a point, add another point here to my table of values. Every time I pick a value to add to my table of values, it slows me down, though. And again, these are spots where I'm happy if you just do it like this, but we'll get these values in MHF4U in calculus. So again, a little bit of sadness for now, but still a pretty good sketch. And that's it. I only have a few for you to try from a handout. Looks like there's lots of questions there, but it's only, I think, 5 questions that are pretty much exactly like these ones. So have fun with those, finding oblique asymptotes. This was perfect.